Okay, some properties of stratified sampling. Population must be organized into non-overlapping homogeneous strata. So one person can't go between two of these subgroups. And every element has got to go somewhere. You can't leave anybody out. This is what this is saying too. And when that person is assigned to a group, they stay in that group. They don't go back and forth between two groups. Now within each group, say Democrats, Republicans, and Independents, within each group, to get the two Republicans here, you can either use simple random sampling or you can use systematic sampling. Now, whichever one you choose, I would stick with that one for each of the subgroups. Now, what this does is, because you took your population and you broke it up based on a characteristic, and then you're going to go into each characteristic and get a sample from each one of those, that's going to help your sample to represent your population better, because your sample will have all the characteristics that are also in the population. Okay, so that's basically what these two things are saying. Now you can break this down into two types, proportionate or disproportionate stratified random sampling. Proportionate stratified random sampling, the sample size of each stratum is proportionate to the population size of each stratum. Okay, so if this whole thing here is my population, notice I have twice as many guys as I do girls. Okay, so that means within my sample, I'm going to have twice as many guys as I do girls. Your sample is going to look or mirror your population. It's just going to be a smaller version of it. Disproportionate, it doesn't matter how many different elements you have or if they're all the same. What you're going to do is, if this is your population here, you're going to take the same amount from each one of your subcategories. And it doesn't depend on how many is in each category. You're just going to take the same amount from each category. So here they're taking only 4 from each category. Okay, and then cluster sampling. Notice that this is, you're going to break your population up into subgroups. This is regardless of characteristic. Okay, so you will randomly select a certain number of clusters, then sample from the entire cluster. So you'll take the whole thing. So here's our population right here, and we've broken them up based on the street they live on. Okay, so we're going to choose one and say it's this one right here. And I'm going to take this, everybody on 3rd Avenue. Okay, would that sample be a good representation of the entire population? Well, no, because I'm missing this blue chick right here. Okay, so this characteristic is not in this sample. So notice, only good if each cluster is a good representation of the whole population, if using a small number of clusters. Here I used 1, and it didn't represent my whole population well because I missed out on this characteristic right here. So I would at least need to look at 2 clusters, okay, just so I get all the characteristics in my population or my sample. Okay, be careful with this. Stratified versus cluster. Many people confuse stratified sampling and cluster sampling. In stratified sampling, you use all the groups and some of the members in each groups. Okay, you have the Republican, Democrat, and Independent. Okay, these are all my groups, but I only use some from each of my groups to make a sample. Cluster is the opposite. It uses some of the groups and all members within that group. So if it was clustered, it would just take this right here. And actually that wouldn't be clustered because this right here, the setup is based on the characteristic. It's like the streets. Okay, I didn't sample from each one of these. I just picked a few of them and took the entire thing. Okay, it uses some of the groups and all the members in each group. So be careful of that. Okay, so this is just a recap. These are true random sampling. You can use simple random sampling, systematic, stratified, or clustered, or random. Remember the difference between random and simple random was random looked at one individual, simple random looked at a group of individuals. The only one that's not listed here is convenience because that is not random. So these are good techniques to use. Okay. The president of DePaul University wants to conduct a survey to determine the community's opinion regarding campus safety. The president divides the DePaul community into 3 groups: residents, non-residents, and staff. So he or she can obtain a stratified sample. Stratified sample. Suppose that there are that many residents, that many non-residents, that many staff, for a total of that many individuals in the population. The president wants to obtain a sample of size 100 with the number of individuals selected from each stratum weighted by the population size. Number 1, what type of stratified sampling is this? Okay, remember stratified sampling is divided into 2 groups. It can be proportional or disproportionate. Notice that I'm weighted by the population size. So if there's twice as many guys as there is girls in my population, that will be the case in my sample. So the keyword here is weighted, so we know that this is going to be proportionate stratified sampling. Okay, how many people from each stratum should be sampled? Okay, so we've got residents. We have 2,000. Oh, no, I'm sorry. We got 6,204. Non-residents, we have 13,304. And staff, we have 2,401 for a total of 21,909. Okay, so this whole thing over here is our population. So, all right, population. We want to get down to a sample of just 100. So we want a total of 100. So we need to figure out how many residents, non-residents, and staff members should we select from our population. Now we said that this is going to be weighted, so I need to know the percentage of residents, percentage of non-residents, and percentage of staff. So what I'm going to do is I'm going to take 6,204 divided by 21,909. Now that's going to give me 0.28, so 28%. And then I'll take 13,304 divided by the total. That's going to give me 0.61, so 61%. And then 2,401 divided by the total. And that should give me 0.11, so 11%. Now when I add all these up, this will be 100%. Okay? So I need 28% of my total to be residents, 61% of my total to be non-residents, and 11% of my total to be staff. So what I need to do now is take 28% of 100. So 0.28 times 100. Move the decimal twice. It's 28 residents. 0.61 times 100. Move the decimal twice. 61 non-residents. 0.11 times 100. 11. So 11 staff. So if I add all these up, this would be 100. Okay? So that answers the second question, how many people from each stratum should be sampled? And then lastly, how can we obtain samples from each stratum? How can we get 28 residents, 61 non-residents, and 11 staff members? Well, there's only 2 options if it's stratified sampling. Right here. Simple random sampling or systematic sampling. So these are the two answers for that last question there. Let's see which sampling goes with each of these situations here. A farmer divides his orchard into 50 subsections, randomly selects 4, and samples all the trees with the 4 subsections to approximate the yield of his orchard. Okay, he's got 50 of them, randomly selects 4 of them, takes all of the trees within those 4. This has got to be clustered. A pollster walks around a busy shopping mall and approaches people passing by to ask them how often they shop at the mall. Okay? A pollster walks around a busy shopping mall, approaches people passing by. Okay? This is convenient. So this is a convenience sample. Maybe that person is by a certain store. Okay? Maybe they're by GameStop versus maybe they're by another store that sells clothing. Okay? So you can have 2 different types of people who are gathered around the game store, or the people that are gathered around the shopping store. Okay. 24 Hour Fitness wants to administer a satisfaction survey to its current members. They number all members in order of their last name and randomly generate 100 numbers, then ask them about their level of satisfaction with the club. Okay, so they listed it all out. Every single group of 100 had an equal shot of being selected. This is simple random sampling, because every group of size 100 had an equal shot of being selected. Police at a sobriety checkpoint pulled over every 5th car to determine whether the driver is sober. There was a system to that. Every 5th car. So systematic. Okay. A member of Congress wishes to determine her opinions regarding estate taxes. She divides these into 3 income classes: low, middle, and high. Then she takes a simple random sample of households from each income class. Don't let this trip you up right here. Okay, so she broke them up into low, middle, and high, and she took a sample from each one of those using simple random sample. So this was based on a characteristic low, middle, or high. So this is stratified. Because remember, one of the 2 ways to get your samples within each subgroup is simple random sampling or systematic sampling, like it says right here. Let me get back to it. Right here. Simple random sampling or systematic sampling. We're going to look at 3 types of sampling errors: random sampling error, non-sampling error, and non-random error. Random sampling error. A sample has been selected with a random method, but there's a discrepancy between the sample result and the true population result. This one is, sometimes you just can't get around this one. For example, someone lying on a survey. Okay? If someone lies on a survey, then that's not a true representation of the population. Mostly because they want to be viewed in a positive light. Okay, so you've got social acceptability bias here. So this one, sometimes there's just no way of getting around this one. But this one, non-sampling error, the result of human error. Okay, say you were putting in data and you were supposed to put in 50, but you had way too much coffee that morning, so you accidentally hit a 0 one more time and you put 500. Okay, so it shot it from 50 to 500. Now this is easy to fix. The problem is finding out where the mistake was and fixing that. But this one you can fix. Incorrect data entry, computing errors. You're supposed to be in feet, but you were actually in inches, something like that.